Bismillahirrahmanirrahim. This video is from Linear Circuit Analysis, chapter number 7 of Mr. Alexander and Sadiku's book. And here I'll be solving end chapter question 7.8, and this is on the request of a student. So this is the question. For the circuit, the voltage is given and current is given. And this is the circuit. We have a capacitor and a resistor. Capacitor is fully charged and it will discharge through the resistor. We have to find these four questions or solve four questions. So we'll tackle them one by one. Okay, keep in mind that we'll be using these formulas. The current through capacitor is C dV dt. Time constant tau is given by RC, and the voltage across the capacitor is V naught e raised to the power minus t over tau. Now the first part of part A says find a resistance and the value of the capacitors R and C. Now if we compare these two, this is the voltage given and this is the general equation from here. Then just compare this part. Minus minus cancels, t cancels. So what is left here is 4 and what is left here is 1 over tau. So 4 is equal to 1 over tau. And from here tau is 1 over 4 and tau is also R multiplied by C, RC. So this is our equation number 1. So we were up to here. Now keep in mind one point, that when the capacitor is charging, the current is flowing from source to the capacitor and the current direction is then from left to right, and the equation we'll write is I C dV dt. But when the capacitor is discharging, then the capacitor is behaving like a source. The current direction is opposite of the charging current direction. So in this case, we'll put a negative sign and use the same formula. So negative I is equal to C dV dt. So in this case also, since the capacitor is discharging, we'll use this formula. And we know I from here, so we'll put that value. We know V from here, so we'll put that value here. So I is equal to C dV dt, and when we differentiate this, we'll get this 10 minus 4 e raised to the power minus 40. I hope you know how to differentiate. Okay, now from here, this term cancels, so we get 0.2 is equal to 40C. So C is 0.2 divided by 40 is equal to 5 into 10 raised to the power minus 3 or 5 millifarad. So capacitor we have found. Now from here we can find the resistance. So R from here is 1 over 4C, and putting in the value of C, R is 50 ohm. So part A is solved. Part B says determine the time constant. We had already calculated time constant. So RC is 1 over 4. So we'll just write it as 0.25 seconds. So this is our time constant. Then part C is calculate the initial energy in the capacitor. So we know the formula for energy is half CV square. So at time t is equal to 0 and the capacitor is fully charged, the energy we'll write is omega 0 is equal to half CV0 square. And now from here, we had found capacitor value. From these two comparing, we can see that V0 is equal to 10. So we'll put this value here. So putting the values, we get the initial energy 250 millijoule at which the capacitor is charged. Part C done. Now part D, obtain the time it takes to dissipate 50% of the initial energy. So the capacitor is charged, now it is dissipating through the resistor, and we need to find the point in time when it dissipates 50% of its energy. Okay, now keep in mind the energy that was initially stored in the capacitor is eventually dissipated in the resistor through this. So this was the energy we had calculated 250. Now 50% of that means 250 divided by 2, that is 125 millijoules. Now we'll use this formula, this saying that energy absorbed by the resistor at any time t. So energy absorbed by the resistor is same as the energy dissipated by the capacitor. So we'll use this formula. And just to give an idea, it will look something like this, the dissipation of energy. Okay, so we put the value now, half or 50% is 125 mJ, half CV0, 1 e raised to the power minus 2t over tau. So this formula, plug in the value of capacitor and V0. So from here, we put in the values. Simplifying, we get 0.5 is equal to 1 power minus e raised to the power minus 8t. Now, 2 divided by 0.25 will be 8. So from here, e raised to the power minus 8t is 1 over 2. And inverting both, we get e raised to the power 8t minus sign gone because of the inversion. And this inverted will become 2. Now we'll take help of log, taking log on both sides. So 8t is log of 2, log natural, and this is equal to 0.693. So from here, t is 0.693 divided by 8, and it is equal to 86.6 milliseconds. So I hope you have been able to follow this. Please let me know through your comments. Thank you.